If you are at all familiar with my channel, you know that I have a lot of videos on using treadmill motors to power shop tools. Greetings, fellow DIYer, and welcome to my video. Why do we use treadmill motors to power shop tools? Because it is a DC motor, and if you vary the voltage, you vary the speed. Now, obviously, the power coming out of the outlet is AC, and that means that we need some sort of power supply to convert AC to DC and give us variability to be able to go from low voltage to high voltage to vary the speed. Most of my videos show you how all these components work. And I keep getting questions and comments saying, where can I insert one of these components? Now, most of my videos have links in the description, but in some cases, you've got to watch several videos and look at several descriptions to get all the links. So, even though this information has been gone over in all my other videos, I decided to put this together and give everybody a one-stop shopping opportunity. I'm going to go through the three basic kinds of power supplies that people use. I'm going to give you a very basic parts list on what is required to make that power supply work. And then you can go into the description and click the links to find the parts that you need, or at least find a starting point. There's nothing saying you have to order the exact same part that I do, but at least it will give you some specs and let you know where to begin. So the first sort of power supply, and the simplest power supply, is to use the original treadmill motor components. We have an MC60 and we have an MC2100. And while these parts do pretty much work right out of the treadmill, there are a couple of components that you need to finish the job out. With the MC60, you need a potentiometer, usually right around 10 kiloohms. These can be had inexpensively from Amazon, eBay, any number of places, and there are lots of choices available. I have other videos showing you how to hook it up to an MC60, so I'm not going to go into that detail. But that's really the only component that you need to make this work, sort of. With all of these power supplies, with maybe the exception of this one, you really should run a motor choke. Now, I don't have a link for this. People have been purchasing chokes that they think are going to work on Amazon, but Amazon doesn't really carry these. I've seen a few being sold by individual sellers that are a used motor choke taken out of a treadmill, but they want big bucks for them. You either need to get this from your treadmill, hopefully find one on eBay, or see if you can get it from a treadmill parts supplier. The other option, if you cannot find one, is to take the transformer out of a microwave and you can convert it into a choke, and that's pretty effective. And I have a whole video on how you do that. So, MC60, you need a choke and you need a potentiometer, and that's it. What about this MC2100? It's probably the easiest power supply to hook up because all you need is this pulse width signal generator right here. You hook this into this, you hook this up to your motor. Now, you do want to use an inductor or AC type choke. A lot of the treadmills that are using the MC2100 come with this. If you don't have one of these, there's a link in the description for just the donut, and then all you have to do is wrap some wire around it and put ends on it. Super simple to make. It's also a good idea with this board to use a circuit breaker. Now, this is a component that you really should use with any power supply. You always want to have a circuit breaker. And I have several linked. This one happens to be 20 amp. 15 amp is also available and linked in the description. So with this power supply right here, pulse width signal generator, AC inductor or AC choke, circuit breaker, and that's all it takes. So as I said, the Treadmill motor components, those are the easiest way to get your power supply going, but they're probably not the best way. I have a video talking about how I'm not a big fan of the MC2100 due to its reliability issues. The MC60 is basically an SCR voltage controller, and while it's good at doing its job, there is actually a better option in the aftermarket, in my opinion, for an SCR type voltage controller. These two are simple, least components to put together, but not, in my opinion, the best option. A very good option, and I have videos showing how this works, is to use a variable transformer. Now this is 100% AC, so it's AC coming in and AC going out, and it's anywhere from 0 to 130 volts. Now obviously we're running a treadmill motor, which is DC, so we have to convert the AC to the DC. You cannot use this directly with a treadmill motor. Enter a bridge rectifier. Now I have two versions here. This one I've bolted to a heatsink. They don't normally come with this heatsink. This was cut out of a heatsink for a treadmill motor control board. So you have this little guy here and you have this big guy here. Don't get this one. You can get 10 of these for like 10 bucks, and well, the amperage is technically high enough and the voltage is plenty high enough. These oftentimes fail. And when they fail, they short out directly and they will burn up your power supply, or at the very least, pop the circuit breaker going into your power supply. I'm not a fan of these. Now, I use these a lot on the bench when I'm explaining stuff to you guys because it's small and it's simple and it's easy to hook up and there's no load on the system. So I can get away with using this one. This guy is 100 amps and like 1600 volts. And it'll cost you right around 15 bucks, and it is the only way to go. I had one guy tell me that this rectifier was too big and he couldn't get it to work with his setup, and that when he switched to this, it started working. Well, one of two things happened in that situation. Either he had this hooked up incorrectly because it does not hook up the same as this one. This guy works opposite. So your AC comes in here, and then you have positive and negative. On this one, you have positive here, negative here, and then your AC comes in here. So you cannot wire them the same. The other potential issue, or why this gentleman was having a problem, was maybe he got a bad one. Now, it would be easy to assume that if this is 50 amps and 1000 volts, and this is 100 amps and 1600 volts, that this is too big, and that's why you're having problems. But it doesn't work that way. All this allows is for more max amperage and more max voltage. The function is the same. This comes with a built-in heatsink. Heat is the enemy of all things electronics. So the fact that this is built with heat sinks, it's going to dissipate heat better. Because this is higher amperage and higher voltage, it's built with better components. I liken it to this. This is a cheap hose like you would buy at a big box store. And this is a high quality hose like you would get at a higher end local hardware store. There is a big difference in quality. There is a big difference in reliability. There is a big difference in overall life and how they function. Don't get this, get this. I'm not even going to link this in the description, but I will link this guy. If you are doing one of these two pieces, you must use a circuit breaker. As I said, from experience, when these fail, they short out, and that will short out your power supply, whether it be an SCR voltage controller or whether it be a variable transformer. By adding a circuit breaker, you are protecting your device. Now, in the case of the variable transformer, it does come with a fuse, so this is not required. But if you're using these with an SCR voltage controller, then yes, a circuit breaker is an absolute required component. If you are using a bridge rectifier, you need to use one of these between your power source and the bridge rectifier. So if you're using the SCR, it's going to go between the SCR and the AC inputs on your rectifier. If you're using a variable transformer, it is going to go between the AC out and the AC in on your rectifier. This helps clean up the power and smooth out power spikes, and it is specifically for the AC side of things. So it is required, in my opinion, if you are converting AC to DC to power your treadmill motor. Do I need a DC choke with a variable transformer? It's not a bad idea, but it's not required. You don't get as bad of brush arcing with this as you do with this. And that has to do with how this works. This is stepping the voltage down. So you're getting a complete sine wave on AC. This is turning off and on, so you're getting bits and pieces of the sine wave. And that's part of why this produces what we would refer to as dirty power. Is a choke a good idea on this? Yes. Why not run it if you have one, or if you can easily make one? But it's not as crucial with the variable transformer as it is with the SCR voltage controller. So that brings us to this SCR voltage controller. Now, it requires the most components, but it's also relatively inexpensive to begin with. The variable transformer is going to cost you $70. This is less than 30. So we're already less than half. You do have to run a choke with this. Now, technically, you could run it without, but you are shortening the life of your treadmill motor. This is converting high voltage AC into low voltage AC. So again, a bridge rectifier is required. If we are using a bridge rectifier and we're going AC to DC, we should use the inductor as an AC choke, and we should use the circuit breaker to protect our power supply should the rectifier fail. The other component you need with this is you need to change out the potentiometer. That's the knob guy right here. Now, these come with either a 350K or a 500K potentiometer. That K stands for thousand, so 350,000 or 500,000. Most people end up needing 120K to 150K potentiometer for their SCR voltage controller. Now, I have a whole video showing you how to test for that. You really should test it on the machine, under the normal load of the machine, with the specific motor that you're going to be running, because the difference between 120K and 150K is pretty significant in the functionality. If your potentiometer is too big, you will have a dead spot at the beginning. So nothing will happen, nothing will happen, nothing will happen. All of a sudden the system will come on. And let's say it's at half. Well, now you only have the other half to get to full speed. So the adjustment is very, very coarse. Like, you don't have to move it a lot and the speed changes a lot. So it's super important that you get the correct sized potentiometer. The other thing when getting potentiometers is the best way to do it, in my opinion, is to get two. Get one that's smaller, say 10 or 15K, and then get one that is bigger and makes up the difference. So let's say you needed a 150K potentiometer. Get a 15K and get 135K. Now, why would we do that? Well, the 15K potentiometer is 15 kiloohms from the most to the least, which means an entire turn of the knob only changes the resistance by 15K. The 135K potentiometer, that same turn of the knob is going to swing it 135K. The bigger the change, the faster the change at the motor. So with the 135K, a little turn is going to increase or decrease your speed significantly. With the 15K, a little turn is only going to give you a little increase or decrease. So I always run two potentiometers in series so that I have the bigger one as the coarse speed control and the smaller one as the fine speed control. And typically on my machines, the way that works out is the fine speed control gives me anywhere from 200 to 300 RPM total adjustability. And then the coarse speed control, there's almost 1,000 to 1,500 RPM of total adjustability. It's just a great way to set it up, and it's the way I recommend. Again, if you're running this, you got to run a choke. Again, anytime we're running a rectifier, we need to run this between the rectifier and the power supply. So what's the rest of this stuff? Well, I have here a couple of project boxes, and I actually have more linked than what are here. I've got this medium-sized guy. I've got a smaller guy that has a hinged front lid. I've got a much bigger guy that has all my ELS parts in it. And then I've also got this plastic one that is a good component box. I prefer a metal box over a plastic box because it's easier to ground everything. But in some cases, the plastic is also a good way to go. It's definitely easier as far as drilling holes and mounting stuff. You really don't want to have your power supply exposed to the elements of a shop environment. You don't want to get metal chips or wood shavings or whatever it is in the shop that you're working on. You don't want to get bits of that in these components. You're going to burn stuff out. So it really needs to go into a box of some kind. Now, if you're going to do that, I recommend cable glands. You don't want to just drill a hole in this and run the wire out because that hole is going to be sharp. And any vibration induced by the running of the machine is going to cause that wire to rub against the metal on the hole that you just created. And ultimately, you're going to cut through the shielding and you're going to have a short. So always use cable glands. All of my boxes are set up with either cable glands or electrical outlet connectors. Same concept. This is typically what you would use for your house electrical, and it just squeezes the wire and keeps it from vibrating and being cut through. With a DC motor, if we reverse the polarity, we reverse the direction of the motor. Now, if this is on a mill or on some projects, that's not required. If you have a lathe, changing direction is totally required. And so I have several toggle switches here. Honestly, none of these toggle switches are truly up to the task. They're all lower amperage and lower voltage than what's going to be going across in this particular situation. But it's also not 100% accurate because all of these DC currents are being pulsed. So it's not the same as a direct DC current like through a battery that's going to provide a constant voltage and a constant amperage. The pulsing nature of your treadmill motor controller, of the SCR voltage controller, even the pulsing nature that you get with a variable transformer is going to allow you to get away with a little bit higher amps. The other thing is you're not breaking the connection or making the connection typically in a high amp situation. So the downside to running a switch that is too small is it's not going to last as long as running something that is correct. But I've had multiple switches in my machine and they've lasted for years without any issue. So my recommendation there would be to get several of them so that you have a backup. Should the connections inside here fail, because that's usually what goes bad, it's just simple as unplugging it, opening up the machine, swapping out the switch, and you're set to go. Now this guy is much higher amperage. It's 20 amp, and it's a heavy duty rotary switch. This is what I'm using in my lathe. Now, obviously this red color is ridiculous. I was able to paint mine black and I've not had any scratches or any issues with it, and I've been using it that way for about 6 months. So the vinyl dye that I purchased at the automotive store and spray painted it with is holding up really well, and so you don't have to worry about the fact that it is such a terrible color. Either way, that's in the description. All these parts are in the description. Now I'm going to basically make a list of all the components, or at least most of the components, your situation might be a little different, required to put together a power supply of each kind. And so some of the parts that are on here are going to get listed under multiple things because we need this rectifier to run this, and we need this rectifier to run this. So look at the specific heading for the type of power supply you're wanting to build, and then below that will be links to the various parts. If you have any questions, you have two options. You can go through the plethora of videos in my channel that talk about the various components, that talk about how stuff goes together, that gives wiring diagrams and shows you how to correctly size a potentiometer and how to set things up. I've got videos on mistakes that people have made. I have Lots of good content that you can sit down, watch, and educate yourself. But let's say you don't have time to do that. There's over 100 videos in my library, and that's a lot of hours of YouTubing. Maybe you just want a quick answer. Well, that's what I'm here for. If you have a question, put it in the comment. If that is something I have covered in one of my videos, I will throw you a link to that specific video. Or if it's something that I can easily answer, I will just answer the question. For those of you that are regular viewers of my channel, I apologize that I am rehashing this, but I cannot begin to tell you the number of questions I get on a regular basis saying, where do I get these components? So I figured, why not put this video together and give everybody the information all in one place? If you like what you've seen, please click like. If you'd like to see more, please subscribe. Thanks for watching.